All right, welcome back. Today we're going to be doing some trig, and we're going to use trigonometry to solve for a missing side of a triangle. This comes into play, say, if you were trying to find like the height of a flagpole, the height of a building, or if you needed to know how much material that you needed to cover from point A to point B, anything. There's lots of application here. But you are going to want to have a calculator nearby. Your phone will work, but remember, order that we plug stuff in might be a little bit different. But you're going to need a calculator. So, I got real creative with these examples today, and they are the exact same numbers, but the setup is going to be different for each one. So let's just dive in, take a look, and see what happens. So, for my first example here, I got a right triangle. I have one angle that's 25 degrees, one side that's 13, and an unknown side, x. So based off of my angle, I need to know what two sides I know. So since my angle is here, I know the opposite side and the hypotenuse, which means I'm going to use sine to solve for x. And I'm going to set this up just like we did, but now we're given our angle of 25 degrees. So this is the sine of 25 equals opposite over hypotenuse. I need to solve for x, which means I need to get x by itself. So I'm going to multiply both sides by x. So I get x times the sine of 25 equals 13. And now I'm going to divide by the sine of 25. So x equals 13 over the sine of 25. This is my exact length of x. But if I needed to know what that was, I'm not going to leave it in that format. I'm going to actually have to plug it into my calculator. Okay, so on my calculator, I'm going to type in the sine of 25. Nope, I'm going to type in 13 divided by the sine of 25. And my calculator is in radians. We're going to actually talk about that coming up shortly. So definitely make sure your calculator is in degrees. Okay, if you're using your phone, it'll say DEG in the corner, which is a good thing. Mine is in radians, so I've got to change it, and then I'm going to repeat my process. 13 divided by the sine of 25, and my distance here is about 30.761. Okay, so all this is algebraic. We knew to use sine because we had the opposite and the hypotenuse. Sine. Okay, so my second example here, like I said, it's the same numbers, but it's going to be a different setup. And the reason why it's going to be different is my angle here is 25. I know the opposite and adjacent side. So opposite and adjacent, that's going to use tangent. So this setup will be the tangent of 25 equals 13 over x. So what I'm going to do here, same idea. I'm going to multiply both sides by x. And then I'm going to divide by the tangent of 25. So x equals 13 over the tangent of 25 degrees. And now I'm ready to plug that into my calculator. So 13 divided by the tangent of 25. And I get about 27.879. Okay, simple as that. It's just algebra, but we had to know that we were using tangent because we had the opposite and adjacent sides. All right, just for algebraic sake, I'm actually going to change this example here, and I'm going to move our positions. I'm going to make this side x and this side 13, just so we can see this example. So, hope you're okay with that, because I did it. Okay, so with this one, my angle is here. I know the adjacent side and the hypotenuse, which means we're going to be doing cosine. So this one is the cosine of 25 equals adjacent over hypotenuse. So for this one, if I need to isolate the x, the only thing I have to do is multiply by 13. So I have 13 times the cosine of 25 equals x. Algebraically, that's way more straightforward. Now I just got to plug that into my calculator. 13 times the cosine of 25, and that one is going to give me about 11.782. Okay? Finding a missing side of a triangle. Good to go.